Hello and welcome to Chapter 4. We'll be starting in Section 4.1, where we will be learning about exponents and their laws. Now before we get started, let's go ahead and review the 3 E's that we learned back in the Chapter R section. We learned that exponential functions, exponential values, can be written in 3 different ways: in exponential form, in expanded form, and in evaluated form. Remember, we talked about 2 to the second power. As an expanded form, that would be 2 times 2. And if we evaluated that, we would find out that that's 4. We can do this with any value in the exponent. 2 cubed would be 2 times 2 times 2. And if you figured out what that was, you'd get 8. 2 to the 4th would be 2 times 2 times 2 times 2. That's getting to be more 2's. And we can keep going, of course, and so on. Again, these are just different ways to represent the same thing. In math, we often represent the same values in different ways: exponential form, expanded form, and evaluated form. So discussing this brings up a good question. What happens if we go lower in values in the exponents? Notice that to move down the chart, we were multiplying by 2 each time. Times by 2, times by 2. Of course, the next one would be 32. So to find lower values in the chart, we could simply divide by 2. 2 to the 1 in expanded form, well, would simply just be 2. There's nothing to multiply it to. And in evaluated form, it would be 2. 2 to the 0, if we wanted to find the evaluated form, again, moving down the chart, we would multiply. Moving up the chart, we would divide. So 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is, 1. 2 to the 0 power is a misconception. A lot of people sometimes think 2 to the 0 power would just be 0, but it's not. 2 to the 0 power is 1. And this brings us to our 2 rules, the 2 laws that we want to talk about with exponents. Throughout the chapter, we'll be talking about these laws, the laws of exponents. And the first one you're going to want to remember is called the 1 law. Whenever you have a value that is raised to the 1 power, well, you just get itself. For example, 7 to the 1 power, well, that's just 7. The other law that we want you to be familiar with is called the 0 law. The 0 law states that any value raised to the 0 power will always be 1. Always be 1. There is one exception, and that is except... Oh, sorry about that. Except 0. We don't actually know what 0 to the 0 power is, and so that's actually considered undefined, and we just exclude 0 from this rule. But any number, 8 to the 0 power, that's 1. 112 to the 0 power, that's 1. Even negative 5 raised to the 0 power will be 1. So again, we'll be building this chart throughout the first couple sections of this chapter. You're going to want to have this written down. And remember, under additional information, I went ahead and wrote out what the law is. Again, any value raised to the 1 power is just itself. And any value raised to the 0 power is 1. Okay, feel free to move on to the practice problems. Good luck. To the boards! It's time for you to try a few using your video notebook. Go ahead and take out your notebook now and try these 3 questions using the 0 and 1 law to see how you do. When you're ready to check your answer, unpause and we'll see how you did. Okay, let's do it. 7 to the 0 power. Well, we just learned the 0 law, that anything to the 0 power is 1. So that's our answer there for number 1. For number 2, we have 12 to the 1 power. And the 1 law states that anything to the 1 power is itself. And so the answer here is just 12. Last of all, we have a to the 0, b to the 1. Ooh, that's applying both rules here. We know that a to the 0, anything to the 0 power is 1. And b to the 1, well, that's just to the 1 power, so that's just itself. So what we have here is 1 times b. 1 times b is just b. Excellent. That's the answer to those 3 questions. Let's move on to part 2 of the lesson. Good luck. Hello and welcome back to part 2 in the first part, we learned about the 0 law and the 1 law, that anything to the 0 power equals 1, and anything to the 1 power equals itself. We want to talk now about 2 more additional laws. The next law is the product law, or product rule, as some people say. And that states that whenever we are multiplying powers, so let's say, for example, we have x to the 3rd power, and we times it by x to the 5th. Now, a lot of people will look at this and say, oh, and we're just going to multiply, and it's going to be x to the 8th. Now, this is a common misconception that we definitely want to try to correct right now. You're not allowed to just multiply powers. In fact, if we took a look at this in expanded form, we could write x cubed as x times x times x times, and then write x to the 5th in expanded form. That'd be x times x times x times x times x times x. I sound like a broken record. So notice that if we look at how many x's we have 1, 2, 3, 4, 5, 6, 7, 8 x's. The answer is actually x to the 8th. And so we come back and we say, wow, we've got x cubed times x to the 5th, and we ended up with 8. So what is the rule? The rule, or the product rule, is when you are multiplying exponents. So if we had b to the x power, and we multiplied that by b to the y power, then you would get b to the x plus y power. When multiplying powers, we add the exponents. So if I had 3 to the 5th power times 3 to the 7th power, well, that would be 3 to the 12th power, because all we do is add the exponents. Or maybe if I had y to the 20th times y to the 40th, we would add the powers and get y to the 60th. The other law we want to talk about is the quotient rule, the quotient law. Now remember, quotient means division. So if I were to have x to the 15th power over x to the 5th, we'd have to ask ourselves, x to the 15th over x to the 5th. Now, some people would jump to the rational conclusion, or an irrational conclusion, of that you just divide the powers. 15 divided by 5 is 3. Again, we're dealing with exponents. They have different rules than normal numbers. This is incorrect, and we don't want to think that way. Again, if I were to write out 15 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I hope that's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I'm too short. So if I were to write 15 x's on top, so in other words, we're taking this and writing it in an expanded notation, and then divided it by 5 x's, also written in expanded notation. Remember, when you have a value in a top of a fraction that's the same as a value on the bottom of the fraction, we're allowed to cancel these fractions out. So this x cancels with this, and this with this, and this. In other words, we cancel 5 x's that are on top with the ones on bottom. And then how many are we left over with? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer to this is x to the 10th. So the quotient rule, if you had to come up with your own rule, notice that we had 15 and then 5 on the bottom. Well, when dividing powers, all we have to do is subtract the exponents. When dividing powers, we subtract the exponents. We could write the rule like this: b to the x power divided by b to the y power equals b to the x minus y. You just subtract the powers. So let's look at a couple examples. If I had 7 to the 11th power over 7 to the 3rd power, what would that come out to be? It would just be 7, and then we would subtract the powers. 11 minus 3 is 8. What about this? X to the 30th over x to the 25th. Again, these are huge numbers. X to the 30th power, that's a big number. To write this out, we don't want to do that. We want to know the shortcut. The shortcut is that when you're dividing powers, you subtract the exponents. 30 minus 25 is 5. So our chart now has 4 rules in it: the 0 law, the 1 law, the product law, and the quotient law. Make sure to update your chart in your notes to have these laws written down. When you're ready to continue, go ahead and press the next button and move on to the practice problems. Thanks for watching. Okay, it's time to go to the boards to give you some practice. Go ahead and pause the video now and try these 5 problems using the quotient and product rule that we just learned. When you're ready to check your answers, unpause and we'll work on them together. Good luck. Okay, number 1. We're going to be working here with x to the 4th times x to the 9th. Now, here we're multiplying, and anytime you multiply powers, you need to add the exponents. So we're going to have x to the 4 plus 9, and 4 plus 9 comes out to be x to the 13th. Excellent. On number 2, we're going to be dividing powers, and when you divide powers, you have to subtract their exponents. So 20 minus 2, that's going to be y to the 18th is our answer. On number 3, we're going to be multiplying powers. Now here we have some big numbers, so we'll just do the big numbers like normal. 5 times 3, well, that's 15. And then with the little numbers, here we're multiplying powers, so we need to add the exponents. That's 7 plus 11. That comes out to be 18. So don't freak out if there's big numbers and little numbers. When you've got big numbers, just multiply them like normal. And then the little numbers, they have different rules. We'll add those when multiplying. On number 4, you've got to apply both rules. Let's work with just the top. Z to the 11th times z to the 4th. Well, when we're multiplying powers, we need to add the exponents. So 11 plus 4 comes out to be 15. Now we'll go ahead and work on the division. When we divide powers, we have to subtract. So 15 minus 5 is z to the 10th. And last but not least, number 5, we've got 3 to the 9th over 3 to the 4th. Well, we're just going to subtract those powers. It's going to be 3 to the 9 minus 4, which is 3 to the 5th power. Notice that the base did not change. We never change the bases when doing exponent rules. See, I had x here, so my answer was x. Here I had y and y, so my base was y. Here I had z, z, and z, so in my answer the base was z. So if our base is 3, we don't change the 3. 3 will still be in our base. Okay, let's get to the last part. Welcome to part 3 of section 4.1. There's one last rule that we want to define for exponents, and that rule has to do with a math sin. Many years ago, a bunch of mathematicians got together and decided that there were some things that they didn't think were appropriate to have in answers. And they came up with calling those things the math sins. And one of the things they said that can't be allowed in an answer is an answer with negative exponents. Negative exponents, they decided, would not be allowed. So you cannot say that my answer is 5 to the negative 1. That is not allowed. That's a math sin. And so what we have to do is address what we need to do with these negative exponents. And so let's talk about it. So at the beginning of the class, we started talking about how 2 to the 4th is 16, and that you could find lower powers simply by dividing by 2. To be able to get to 2 to the 3rd, well, that's just 8. We divide by 2. To get 2 squared, well, we know that's 2 times 2, but you could take the previous one and divide by 2. And to get 2 to the 1, you take 4 divided by 2. And we found out that 2 to the 0, in fact, anything to the 0 power, for this same reason, is 1. So the question is, what is 2 to the negative 1 power? If we have a negative exponent, what does that do? Well, it simply follows a pattern. It divides by 2. And so if we took 1 divided by 2, we find out that 2 to the negative 1 power equals 1/2. So anytime you have a negative exponent, you might want to think of it as being the elevator rule. I like to think of it as an elevator rule. The negative power causes the base value, to drop to the opposite location of the fraction. So notice here we had 2 to the negative 1. We could say that's a fraction. 2 to the negative 1 over 1. We can get rid of the negative exponent by making it positive by elevating it down. Look at another example here. We could have 5 to the negative 2 power. Well, negative 2 power, we said that's a math sin. You can't have negative 2's. And so we need to simplify it. So we elevator it down, and it becomes 5 to the 2 power. Notice that when you change the location of a fraction, your exponent becomes the opposite sign. And then you can simplify. We know that 5 squared is 1 over 25. If we take a look at a few more examples here, we can help to illustrate exactly what happens during the negative exponent law and when we apply it. Here, let's look at this first problem. It says 1 over p to the negative fifth. Well, we said it's a math sin to have negative exponents. You're not allowed to have negative exponents. So we can apply the elevator rule. It would move to the opposite location of the fraction. Right now it's underneath, it's in the denominator. So this would move to the numerator and become positive. That would be our answer. 1 over p to the negative fifth really is just p to the fifth. Look at the second one here. The second one, we have b to the negative 2 power over z to the negative fourth power. Well, again, a negative exponent, we apply the elevator rule. They can go to different locations in the fraction and become positive. So this will come up into the denominator, into the numerator, and we get z to the fourth. While this elevators down and becomes b squared. Again, negative exponents move you to a different location in the fraction. Here we have x to the negative 3 power. Well, that's going to have to go down because we're not allowed to have an answer with negative exponents. And so when it goes down, the 2 stays on top. It doesn't go with it because the 2's not to a negative power, but the x does go down, leaving us with 2 over x to the third. So in our table, to write this, when we have x to the negative a power, we can write that as 1 over x to the a power. Or, if we have 1 over x to the negative a power, and it's in the denominator, well, that can become positive by moving it to the numerator. An example could be 3 to the negative 2 power. 3 to the negative 2 power would be 1 over 3 squared, which simplifies to be 1 over 9. One more example could be 1 over 2x to the negative 3. Well, in this situation, we can't have negative 3 power. That's going to have to come up, and the answer would be x to the positive 3 because it comes up over 2. The 2 does not go with it. So in summary, we can state that when given a negative exponent, the value and the entire power should be moved or elevated, if you want to say elevator, it's fun to say, to the opposite location in the fraction. The exponent then becomes positive. So when you move a power to an opposite location in the fraction, that changes its sign. Okay, thanks for watching. Continue on to the problems, and good luck. Okay, it's time for you to try 4 more problems. You can go ahead and pause the video now. Try these 4 problems in your notebook, and then we'll see how you did. You can unpause, and we'll check your answers. Good luck! Okay, x to the negative 8. Now, we're not allowed to have negative exponents in an answer, and so we're always going to have them ride the elevator. I call it the elevator rule. So we're going to go ahead and bring these x to the 8 down into the denominator. And now it's positive exponents, and that's how we would write our answer. In question number 2, we're going to need to apply the division rule. When dividing powers, we subtract the exponents. So it's going to be x to the 5 minus 12. And x to the 5 minus 12 is x to the negative 7. Now, we don't want to leave our answer like that. We've got to have them ride the elevator. And so we get 1 over x to the 7th as our answer. Okay, let's try this question number 3 over here. Here we've got division of exponents. When we divide exponents, we need to subtract the power. So we're going to have y to the negative 3 minus a negative 7. Ooh, there's a lot of negatives right there. So notice, when you divide powers, you subtract the exponents. So I'm doing negative 3 minus a negative 7. Negative 3 minus a negative 7. Now, a minus a negative is going to make this plus. So here we have negative 3 plus 7, which comes out to be y to the 4th. Excellent. Question number 4. I'm going to do the product rule here. When multiplying powers, we add the exponents. So that's going to be z to the 4 plus a negative 10. Ooh, 4 plus a negative 10. That's like 4 minus 10. So that's minus 6. All over z to the 3. Okay. Now we're dividing powers. Ooh. So we have z to the negative 6 divided by z to the third. When we divide powers, we subtract the exponents. So it's going to be z to the negative 6 minus 3, because we have to subtract the powers. Negative 6 minus 3 is z to the negative 9. We can't leave our answer like that. We're going to have it ride the elevator. And so the final answer would be 1 over z to the positive 9. Remember, we always want our exponents to be positive. So if you do have negative exponents, move them to the opposite location in the fraction. Thanks for watching, and good luck with the assignment.